Good afternoon for everybody. My name is Guilherme Moraes, and for me, it's an honor to participate in this event. And in my presentation, I'm going to talk about domain adaptation and zero-shot models. Specifically, I'm going to talk about domain adaptation to the legal domain, and also about a proposed zero-shot approach to the task of legal case entailment. Legal case entailment is the second task of the quality competition in which we got the first place. But before starting my presentation, I'd like to introduce the other authors who participated in this work, which are Juan Chaves, Roberto Lotufo, and Rodrigo Nogueira. Well, I'm going to start my presentation by talking about zero-shot learning and also about some related works that have applied zero-shot models to domain-specific tasks. Then I will briefly present some topics to provide a background on our work. Next, I'm also going to explain the zero-shot model that we use and how it was adapted for the quality task. And to finish, I will present the results and the main conclusions. So let's start. Well, recent evidence shows that models trained on large and diverse data sets can achieve good performance in many out-of-domain tasks, and we can consider this situation as a zero-shot scenario since the models were never trained on data coming from the target domain. In addition, we also know that zero-shot and few-shot models are becoming more and more competitive with fine-tuned models. So to test this new evidence and also to investigate the zero-shot ability in the legal domain, we participate in the legal case entailment task of quality competition, and we were able to achieve great results using models with no adaptation to the legal domain. But I have to say that we were not the first to try this kind of approach. For example, using the same model used in this paper, Nogueira et al. Demonstrated a zero-shot approach that performed better than trained models on the test set of track robust. Another good example is Zhang et al. He used a zero-shot model to create a search engine to information about COVID-19, and his model was able to get a good performance on the track COVID dataset without being trained with any data about COVID-19. And there is also the work of Pradeep et al. He applied a zero-shot approach to achieve the best or second best performance in specialized tasks of the text retrieval conference, for example, the track precision medicine and track COVID tasks. Well, a common feature of all these works that I've been talking is that the models were only trained on a general domain data set, and they didn't need any domain data to achieve the good results. But despite all these works in different domains that we have in literature, as far as we know, there is no strong evidence that zero-shot models have this similar behavior on legal domain tasks. So, until now. So, the main contribution of this work is that we show for the first time for the task of legal case entailment a zero-shot model that performs better than models adapted to the legal domain. But before going into detail about the proposed approach to this task, I'm going to explain some important topics to provide a background about the presentation. Well, the first topic I'd like to talk is zero-shot domain adaptation. Zero-shot domain adaptation is when a model is able to solve a task in a target domain without receiving any trained examples in that same specific domain. In our case, the model has never seen text from legal domain, and it was only trained on text coming from general domain. Now, speaking about the quality competition, quality is an annual competition promoted by the University of Alberta, and the goal is to improve automated systems on legal tasks. And among the 5 tasks of this year competition, we participate in 2 of them, the legal case entailment task and the legal case retrieval task. And in this presentation, I will talk specifically about the approach we propose to the task of legal case entailment. The goal of this task is to identify a set of paragraphs from existing legal cases that are relevant to a new case. And as you can see in the table, our submissions got the 3 top scores, achieving more than 6 points above the second best team. Also, in our experiments, we use 2 models that are the beta and Monotip 5. The beta is an improvement over some previous transformer architectures like BERT and RoBeta, and this model is the state-of-the-art in many NLP tasks. The second model we use in this work is Monotip 5. Monotip 5 is a model adapted to the task of text rank, and it is based on the T5 architecture. Monotip 5 is also state-of-the-art in some information retrieval tasks, and it is the model responsible for the zero-shot approach we use in this work. And on the next slide, I'm going to explain how Monotip 5 was trained on a general domain dataset and apply it to the Colli competition task. Well, as I said, Monotip 5 is an adaptation of the T5 model for the task of text rank. The model was proposed by Nogueira et al. In the year of 2020, and the model was trained on MS Marco dataset, that it is a big dataset with 500,000 of text passage, and it was built for the tasks of text rank and question answering. Well, during the fine-tune step, Monotip 5 is trained to generate the tokens true or false, depending on the relevance between a document and a query. And to train this model, we use this input template that I show in this image on the left in green, where the letter Q represents the query, and C is the candidate document that may or may not be relevant for a specific query. On inference, the model estimates a score to quantify the relevance of a document to a query, and this score is given by the probability assigned by the model to the token true. Well, in this slide, I present the results of the experiment. All models were trained and evaluated using the Colli competition dataset, except for Monotip 5 zero shot that was trained only on MS Marco. And the approach we use for this task is considered zero shot because the model was trained and evaluated on datasets coming from different domains. In this case, we trained it in a general domain text and using the MS Marco dataset. So our zero shot model has never seen text from the legal domain during training, only during inference. And as can be seen in this table that I show, the results shows the efficiency of the zero-shot approach, because despite not having been trained in any data coming from the legal domain data, Monotip 5 zero-shot achieves a better performance than the beta and Monotip 5 models that were trained on the Colli dataset. In addition, our zero-shot model achieves the best result of a single model in this task, and also performed very close to the beta T5. The beta T5 is an ensemble between the beta and Monotip 5 models, a combination of both models, both trained on Colli dataset and considered the best submission for this task in the competition. Well, it is important to note that despite the beta 5 performance being the best among all submissions in this competition, this ensemble demands training time, computational resource, and also data augmentation to perform well in the legal case entailment task. While Monotip 5 zero shot doesn't need any adaptation. The model is already available online and it is ready to be used. Now, coming to the conclusion of the presentation, I'd like to say that in this work, we show for the first time for the legal case entailment task that models without fine-tuning to the target task can perform better than models trained to the task itself. The results show in the legal domain a counterintuitive finding similar to other domains that, given limited label data, models with no adaptation to the target task may be more robust to change in data distribution. They also may have a strong generalization ability, and they also tend to perform better on held out data sets than models trained on the target domain. We also know that domain-specific models and adjustments made during the fine-tune process are promising directions for future research, but we believe that zero-shot approaches are very important because they allow the development of high-performance systems for tasks or for domains that have low availability of data. And a good example of this scenario of low availability is the legal domain. And in addition, the zero-shot models can also be used as strong baselines in our experiments. Now, to conclude, it is important to say that this research may have implications for new experiments beyond the scope of the legal case entailment task. And it is also possible that other legal tasks with limited label data, for example, the legal question answering task, could also benefit from our zero-shot approach. And now, before finishing my presentation, I'd like to introduce you to the members of the NeuroMind team. And to conclude, I'd like to thank you all for watching.
Thank you very much, Mr. Guilherme, for your brilliant presentation. It is very nice for us Brazilians to have you here. And now I have one question from the audience. So Mr. Marcelo Lopez from the organization team, he's asking, what are the main difficulties in using fine-tuned models in the legal domain?
I think that the main difficulty is the low availability of label data to fine-tune the models. That's why we are proposing this approach using a zero-shot model.
Perfect. Thank you very much, Mr. Guilherme. Now you have one last minute for a last talk, please.
I simply would like to thank you for the opportunity, and it's a pleasure to participate in this event.